All right, here you go. So completing the square. So I'll move the 3 over, group my x's together, x squared minus 2x, group my y's together, y squared plus 6y, and boot that 3 over so I end up with negative 3. Everyone ready to help me complete the square twice now? One for the x's, one for the y's. So when I do it for the x's, got to find the new c value. X squared minus 2x. What's the process of finding the new c value? What's half your b value? Negative 1, square it, 1. So I'm going to add 1. And then I'm going to do the same thing for the y's. Y squared, half your b value, 3, square it, 9. So I'll add 9 to that side. Here's the one part everyone forgets tomorrow in the quiz. They leave it unbalanced. What do I have to add to the right to keep this balanced? Add 10 to the right. Everyone good so far? All right, now let's keep going. One more step to completing the square, and that's to factor each of those. What was half your b value for the x's? So it's going to be x minus 1 all squared. Half the b value for the y's was 3. So I have y plus 3 all squared equal to 7. All right, let's pick off the center and let's pick off the radius here. Center here would be 1, negative 3. And what about the radius? If that's 7, what must have been the radius length? Now 49. How did I get 7? By squaring what? Remember, this value is r squared. So r squared is equal to 7. What's the value of r? The square root of 7. Okay? We okay here? Yes, Ethan.
Okay, so what if for the y squared it's just negative y squared and there's nothing else? What do you do with that?
If it's so you want x squared minus 2x minus y squared equal to something like negative 3. Shouldn't be negative y, shouldn't put you in that predicament of negative y squared, because it should always be x squared and plus y squared. Okay, so it shouldn't be in that predicament. Other questions? Now say both of them are negative, then you can multiply by negative 1 to get them positive. Okay, if both of them, but one, they shouldn't be opposite each other. Let's just say that. Okay. Anything else? Good questions here. Before we get to any proofs, anything else you want me to touch upon? What's up, Madeline? Let's roll. You want to do one? Okay. Actually, you know what? You guys have one in your packet probably. So instead of you guys trying to copy one, I put a couple in your packet. I know that. If you guys look in the back, anyone look intimidating that we should try out? So we got 23, we got 24. 23, 24, what are we thinking? 24 looks intimidating. 24? Okay, 24 it is. All right, let's see. Accompanying diagram. Ooh, we got a diameter, a radius. Tangent DOB is 55. Got it. I think that's supposed to be an arc. Do you guys have an arc symbol on yours or no? It should be arc AF there. The measure of arc AF is 25. Because there is no other AF. All right, ready? Remember the power in the big dog circles if you know all the arc measures. Don't even look through parts A through E yet. Can you help me find the rest of the arc measures right now? Arc AF is 25. What's arc FB have to be? 155. How do you got? Some of you are wondering, how the heck did you know that? What did it tell me AOB was, or AB was in the diagram? Diameter makes a half circle worth 180 degrees. Any way I can use that 55 to find another arc measure? That 55 is what type of angle? Central. Central is always equal to its arc measure. So DB is 55. And now what about AD? 125? Again, because AB is a diameter. Guys, please stop me here. If everyone all right how I'm finding all these arcs? Because now I have all the arc measures. I should be ready to roll. Questions? Okay, DB, already found part A, 55 degrees. DCA, where's it located, guys? DCA, outside the circle. So is that adding or subtracting the arcs? It's always subtracting. What are the two arcs in between? I really didn't want to go to the numbers today because we're reviewing, but two arcs in between, 125 and 55. So 125 minus 55. That angle on the outside, is that 0, 35? I got that one, 35? All right, 35, and again, put it in there. Label it as 35 degrees. You never know. Might need it down the line. Guys, somebody classify AEF. What did we call angle AEF? Inscribed, central, or floater? Floater. Is this when I add or subtract? You add two arcs. Okay, AEF. What arc belongs to AEF, and what's the measure? What's the measure of the arc that belongs to AEF? 25. And its vertical angles arc? 55. 0, 80, half of 80, 40. Okay, here's one where we usually have some issues with. CDF. Let me highlight it. CDF. It's not inside, it's not outside. It's like a half and half, right? It's in between. How's it formed? What's FD? It's a chord. What's CD? Tangent. Anybody remember the rule for an angle formed by a chord and a tangent? Half the arc in between. Everyone see what I highlighted there? See the arc in between that angle. It's going to be half of arc FBD. FBD. So that'll be what? Half of, what's that, 0, 210? How's the math? 210? So 105? Can I get some, I'm just doing this. Answer keys up on Aspen. So that's 105, this angle right here. And finally, EDO, everybody. EDO. Ooh. Anybody want to tell me why that's not an inscribed angle? I know that, look, the vertex D is on the circle, but why isn't that not inscribed? Go ahead, Kay. Yeah. DO isn't a chord. Remember, the two sides of an inscribed angle are a full chord. How am I going to find it then? Because I'm not going to find it using any circle facts. That's for darn sure. Go ahead, Ella. I could do ODC. Yes. How are you going to find ODC? You could, yeah. Okay, everyone see where she's going here? She's finding ODC because it's part of triangle ODC. 55 and 35 already add up to 90. So that's got to be a 90-degree angle. And we knew the whole thing added up to 105, so this angle's got to be Was anybody else going to find it a different way? Because Ella threw me off there. That's not the way I was thinking, but it's the correct way. Jack?
Well, it's a radius and a tangent.
So you're saying you knew this was 90 already because, okay, not the angle I'm trying to find though, right?
No.
Okay, this angle right here was 90, yep, because it's a radius drawn to a point of tangency. And then, again, that's 90, yep. What about, can you find the angle next to it? They're supplementary, right? What about this angle right here? This is, if that's 40, the vertical angle's got to be. So you had 40, you had the supplementary angle, and then you could find ODE. Okay? A lot of different ways here. A lot of different ways. How'd that go, Madeline? All right? Everybody else all right on that big circle one? Anything else? If we get to the proofs, we get to them. If not, that's fine too. Anything else up here? Now that you guys feel a little bit more comfortable, it looks like, asking questions. Anything else we got to go over? Yep, Rose. Okay. Let's see what your packet has. Nope. If anybody sees one, you can let me know. I don't want the angles. There we go. Looks like 12, I guess we'll start with. All right, what am I looking at? A tangent and a secant. Yep, same. If the length of the secant segment is 12, so the length of the entire secant is 12, and the length of the external segment is 3, find the length of the tangent segment. All right, what do I have to remember here as far as the lengths of tangents and secants? Whole times. Okay, so whole secant was 12. External part is 3. And what do we know about the whole and external part of any tangent? It's always the same, so x squared. And tomorrow I can tell you it won't be this easy. As far as the algebra goes, you may have to factor or use quadratic formula from what you're left with. Yeah, x equals 6. All right, let me try to find that's tangents and secants. Let me find a chord one. I don't know if I put one on here. I put a chord one on here. I don't know if I put chords on here or not. And also, I don't know if you look on page 50 and 51, I put all the theorems we've gone over. Okay, so if you guys need all in one spot right here, 50 and 51 are all the different theorems that we've gone over. It doesn't look like I have a chord one on here. Actually, AB is 6. Yeah, we can. Here you go, right here. Let's go to 10. 10 and 11. AB 16, CE 16, find ED. Got it. Can somebody apply a theorem right now? That's going to help me out. Shad? Diameter, perpendicular to a chord, what's it do to the chord? Bisects it. So if chord AB is 16, AE will be 8, and EB will be 8. And it's telling me CE is 16. What are you guys setting up to find X? 2 intersecting chords right now. 2 intersecting chords. What can I set up to find X? Give me the 2 segments on one of the chords right now. One chord is split up into 8 and 8, and the other chord is split up into 16 and x. So 64 equals 16x, x equals 4. And again, these are just basic applications of what you guys are asking right now. So, all right. Again, you may set something up tomorrow where you're going to have to factor or use quadratic formula. You guys ready for the proofs? Ready to tackle a proof? We haven't done one in a while here. Okay, 25. Tangents, perpendicular lines, and OE is the same as OF. Prove the two triangles congruent. Yes, again, I know the test is on the third part of the circle unit, but the theorems we're going to use for this one come from the entire unit. All right, before I begin, let's list off 5 ways of proving these triangles congruent. 5 ways. What do you got for me? I'll go side, side, side. You're welcome. Side, angle, side. I have no idea what to say, but I think I heard an angle, side, angle. HL. Angle, angle, side. There you go. Just reviewing the 5 different ways. Okay, anybody got anything here for me? Let's go, Rose. What do you got for me? Thank you. I respect that, Rose, because you didn't take the easy way out right off the bat. AB, congruent to AC. Tangents, drawn to the same external point, are congruent. Yep, little party hat theorem. Rose got you a pair of sides. Let's roll. Frank? Whoa, whoa, ho, ho. Trying to earn some serious respect from me. BD is congruent to DC. Actually, I should have put 4. I'll put 4 on these. Anybody know why Frank's correct? Why those chords are congruent? Luke? Hey, that's why they gave you these 2 segments were congruent. These 2 chords are the same distance from the center O. All right, so if 2 chords, so chords equidistant from the center are congruent. Yep. Equidistant. Anybody want to take it? You had no choice, Evan, so I didn't lose any respect there. I got to have some for you to lose some anyway. Reflexive, too harsh, weak 35. What? 35? I don't know, might 34, 33. I don't know what we're on. There's 40 in the year, so maybe I'm just hoping it's 35. And then this is a pretty easy method now, proving the triangle's congruent. Side, side, side. Just quickly before I get to the next proof, let's just say I change the proof statement from the triangles being congruent to, let's say, these angles being congruent. What would be my next step? CPCTC. All right, I just wanted to, we haven't gone over many proofs in a while, so I just want you to remember all the ways. CPCTC. Questions before I go on to another proof? Okay, that's proving the triangle's congruent. Can you help me prove two triangles similar now? 27. Proving two triangles similar, and there's really not much here for you. I just gave you a tangent, a diameter, and a secant. Quickly here, before we start, 3 ways of proving triangles similar. 3 ways, Skylar? Angle, angle. Anybody remember the other 2? Madeline? Side, 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 meaning all 3 sides are in the same ratio. And side, angle, side. A pair of angles are congruent, sides are in the same ratio. Which one predominantly do we use in a proof? Okay, so that's what your goal is right now. Help me get 2 pairs of angles congruent. Now, before you guys start, notice, please read the proof statement in detail. I am not proving the 2 smaller ones similar. All right, I am proving the bigger one, ADC, similar to one of the smaller ones, DBC. Please remember that. I'm not proving the 2 smaller ones similar. So I need your help. Bigger one and that one smaller one. Can you get me 2 pairs of congruent angles? Evan?
Angle of DBC is the right angle
How do you know that?
because the chords go to the ends of the diameter.
And okay, what type of angle is it? Inscribed and it's drawn to a diameter. That's a theorem we have, isn't it? Inscribed angle drawn to a diameter is a right angle. So angle, yep, we'll start right there. Angle DBC is a right angle. Inscribed angles drawn to a diameter. Or you can say semicircle, that's fine too. All right, to a semicircle are right angles. Nice job. That means then, if there's a right angle in that one, there's got to be a right angle somewhere in the large one. So they can be congruent to each other. All right? If there's a right angle in the smaller one, DBC, there's got to be one in ADC. And where is it and why? And why? Joanna, let's go. Okay, explain why. Okay, hold on 1 second. This next step is not going to say that she is correct that ADC is going to be a right angle. But what's the theorem again? The theorem doesn't say it's a right angle. The theorem says these 2 are perpendicular, right? So my next step isn't a right angle. It's to say that OD is perpendicular to that tangent AD. Because the theorem says the 2 lines are perpendicular, not that they're a right angle. And this is a wordy one. Diameter or radius, whichever one. You want to put radius? We can put radius. Radius drawn to, where do we draw it to? What's that point D called? Point of tangency. Radius drawn to the point of tangency is perpendicular to the tangent. Now you could say it's a right angle after you tell me the lines are perpendicular. Whew. Feel like this is going very, very well today. Angle ADC now is a right angle. Why is it a right angle? No circle fact, but because I know perpendicular lines form right angles. I still got to tell you what about those two if I'm going to do angle, angle. Still tell me they're congruent to each other. Right angles are congruent. All that work, all that discussion, that's only one pair. There's still another pair out there. There's still another pair somewhere out there. And it has nothing to do with the circle. What's up, Braden? Oh, I thought you were raising a paw. No. Sure, go ahead. Is an angle C a full angle in both triangles? There it is. Angle C is shared. Whew. What were the triangles again? ADC and DBC. What if I wanted to say the sides were in proportion next? What would be my reason? What if I wanted to say two pairs of sides were in proportion? CSS, TP, yep. And then what if I wanted to go a step further and say that the means, and if I wanted to say that segments multiplied were congruent? Product of the means equals product of the extremes, yes. Oh, that was awesome of me. And I'm not trying to waste time. There's a reason I'm going over all this. All right, questions there? Anything? Last opportunity to ask questions on anything here. The proofs, anything I had up here on what's going to be on the quiz. Because I'm going to let you go. Yes? Because you weren't here yesterday? I'll go over one. I'm not going over all four, though. Okay, so I have tangent. I have inscribe a square, inscribe a triangle, and inscribe a hexagon. I have those four that we did yesterday. Tangents, all right. I want to line tangent to P. I want to line tangent to P. Just using your straight edge and a compass. A line tangent to P. That's it. What do I have to do? You guys over here yesterday. First step here. If I'm going to construct a line, what do you got there, Rico?
Extend the radius.
I'm going to draw a radius, not just to point P, but to through point P. Because I know there's a theorem, help me out. I know there's a theorem that says a radius drawn to a point of tangency is what? Perpendicular to this tangent line. So what I'm going to try to do right now is take my compass and straight edge and make a line that's perpendicular to your radius. It's got to be perpendicular to the radius and going through P. Where's my compass go first, everyone? On P. And what's your goal? Make an arc that intersects your extended radius in two spots. All right, there it is, intersects in two spots. From here, where's my compass go? On either point of intersection. And I'm going to make a second arc above or below the radius. It doesn't matter. keep my compass the same, opening, go over to the other point of intersection. There we go, make another arc so they intersect. I'm going to grab my straight edge, line it up, line this point of intersection up with point P, and draw in my not a great looking tangent line. There we go, much better. How do I know this is tangent? Because I'm guaranteeing this line is perpendicular with the radius. So it's got to be a tangent line, if that's the case. All right, we good? Questions? Yes. Yes. It should be good. It should be fine as long as you get those 6 arcs. The 6 arcs are all congruent. Okay. Other questions? It's cute. Other questions? Okay, you still have 2 more proofs left that I didn't do, so if you want to try those, you can. And then you also have the rest of the packet. Answers are up on Aspen. I'm not checking a thing tomorrow. You do what you think you need to do. All right, I'll be here after school if you want to sit down and review any of those concepts even more. All right. Answer key and work, I believe, are all up on Aspen.